Welcome back to the channel. We know it's been a little while. We almost forgot how to do this YouTube thing, but we greatly appreciate those of you who have been commenting and still been watching our channel. So it's getting late, but I want to get started on these exterior lights for my building. We're going to go right up there at the peak, and I'm going to have one right on the other side of the building. So this is the light that I'm installing, just a LED light. And for the box, I'm going to use this shallow box. And the reason is because I don't want this to look goofy. I'm kind of a stickler for the way things look. So I kind of wanted to have a low profile here. So these metal boxes, they come galvanized. I painted the edge because I kind of care what it looks like. So how this works is you have these knockouts. So I'm going to knock out one of the ones on the edge. Okay, and you're left with a hole to where you can put your Romex connector in. And then on the other side, you just screw the little washer on. And then you just push your Romex through and tighten that up. What I've started using are these little plastic push connectors. And these are really handy. They won't fall out, and as soon as you put the Romex through there, that thing is not coming out. I've used these things a lot and I've never had an issue with them. So since I'm just going to be up at the top of the building, I'm just going to show you how I'm going to do this. So how this is going to work is I'm going to take these screws out and I'm going to screw this into place, and then this light sits right over it, and that screw here in the middle just screws down and holds the lamp in place. So with this grounding screw, what I'll usually do is take bare copper wire from a piece of Romex and just make a pigtail out of this, and I wire nut the ground wire of the light onto the pigtail that I made. And I just do that because I find it easier than while I'm up there or holding any light really. So they're trying to wrap this around this screw. So above the garage door, I have that metal upright, and that's what I'm gonna screw the light in, the light box into. And the hole that I have for the knockout is gonna be just off to the side. I'm gonna drill a hole in the metal, and so the Romex will come through. And what I'm gonna use to connect the box to that post are these self-tapping screws. And you can tell they're self-tapping or self-drilling screws because of the little bit that they have here on the end. So I'm going to mount the light on one of those flats, probably that last full flat space up at the top. And what I'm going to do is come in from the back, drill a small hole where it needs to go on the outside, and then I can go from the outside and use a different bit to open up the hole so that Romex connector will fit. So I'm going to be using one of these step bits to open up that sheet metal to accommodate the space for this Romex holder. I don't know if you can see it, but there's marks on here showing the different sizes. So you can tell that my bracket isn't going to be going straight up and down, and a lot of times that's super important. So you want to make sure that these screws are 90 degrees, either perfectly horizontal or perfectly vertical. I don't really care on this because all it has is one screw in the middle that's going to hold the light. There's different color wire nuts because they're different sizes. And if you go to Home Depot or Lowe's, if you look at the back of the packaging on the wire nuts, it'll tell you how many wires and what gauge will accommodate what size of wire nut. And that's pretty important because you don't want to get them too big to where they won't hold your wires, but then you don't want to get them too small to where they kind of push the wires out of the way. So as you can see, using that low profile box, it sits pretty well against the building. All I'm going to do after this, I'm not going to bore you with it, but I'm just going to run silicone around the outside. especially because there's a little bit of the hole showing. So obviously I don't want any weather or bugs or anything in there. But I've seen some of these light fixtures to where people go put a full-size box on there and then the light will stick out a little ways. And I don't like doing stuff like that because I think it looks like garbage. The wire's just kind of hanging there. And the reason is because once I get done with the framing, I'll go ahead and staple it up properly. But this box over here, next to this front side door, is the box that's going to power that light. And in multiple gang boxes, they call them gang boxes, where you're going to have multiple switches, you want to have a little bit of I don't know, artistic know-how, or just like a little bit of common sense when you put these in order. I've gotten jobs to where people literally want me to show up and just switch the positions of the switches because the contractor put in a switch that was, to like some lamp or something in the corner that didn't matter. But then the first one that the first switch they'd come to is like the switch that would power the lamp, and then the other one would be like the switch to the main room. And so what I'm going to do in this particular box is, as I walk in, the first light that I want to come on are all of these center lights, because that's what's going to mainly power or mainly light up the building. The middle switch is going to power this light right here, just for this front little cubby area. And this third switch is going to be the most out of the way. Think about it that way. It's going to be the most out of the way when you walk through the door. And this switch right here is what's going to power this light. And I know it sounds weird, like why would you want this light off? But I don't know, we're kind of partiers. We like doing stuff outside, having fires, things like that. So whenever we're having fires or doing things outside where we don't want the light, we can just come in here and shut this off. And in my other building, I have the same thing set up to where I have exterior lights, and then whenever we're gonna have a fire or something like that, or outside movie, we just go flip the switch and then all the lights are out. So I have my wires labeled coming into the box, but this is quite the rat nest, isn't it? So I'm gonna show you how to decipher this. I'm gonna kind of draw this out for you. And so you can see you have the 3 wires in each piece of Romex together, but the main thing is what switches do they go to and what do they end up powering? So I know I went over it in another video, but let's just kind of review it one more time. All a circuit is a complete loop, and all it is a flow of electrons, which is your current. And so all we're doing here is, let's just say that we have our panel box here. Here's our panel box, and then we're gonna have a switch, and then we're gonna come over to a light. The electrons have to flow through this circuit. So using our Romex, what do we have here? We have a panel box, and we have the black wire, and then we have the white wire, and then we have the green wire. And you can see some of this stuff in my other videos if you want it, if you want to review those. But essentially what you have is your black wire, which is your hot wire. It's where the electrons are coming from. So the electrons are coming from, bad job of drawing an arrow. So the electrons are coming from the panel box. So they're gonna come over to our switch. Now all this switch does is break the black wire. It doesn't connect to the green wire or the white wire. It's only there to break the black wire. So what's that? So what that's saying is we have our circuit, and all of a sudden we have a switch right here. All that's doing is breaking the black wire, so electrons can't flow and the circuit's broken. And so what we have is electrons coming from the panel box up to our switch, and then after the switch we'll have a light, and then from the light, this is where our white wire and the green wire travel back to the panel box, and they complete the circuit in the panel box. So since the black wires are taking current somewhere, they're actually powering the device, whatever it is, a light or an outlet or whatever. In this case, it's just lights. Then these need to go to specific places, because these need to break the circuit at certain places. That's why we put switches here. But for your grounds and your neutrals, they can all get put together, because these wires don't really dictate what comes on and what is powered and what isn't powered. All these are doing is returning or completing the circuit back to the panel box. So what you do whenever you're hooking up switches is you can just connect all of the grounds and you can connect all of the neutrals together. So I was at Home Depot one day and I was doing a pretty big electrical job and I was looking for wire nuts, and the guy said, "Have you tried these?" And I'd never seen them before. They come in, there's connectors that have 2 holes that'll connect 2 wires, 3 holes obviously connect 3 wires, and then these are 4 holes that'll connect 4 wires. And all you do is strip the wire back about 3/8 of an inch, and you just push the wires in, and these little clips hold these in here. And I've been able to pull these out, but I had to literally rip them out with channel locks. So maybe there's some people that are skeptical about these, but I think these work a lot better than wire nuts. You know, wire nuts, you're kind of blind. You don't know what the wire is doing behind the wire nut or underneath the wire nut. But these are nice because when you push these in, they're clear and you can see that the wires made contact with the metal inside, and then it can reach all the way to the front, so you know that you made a good connection. This is going to be the simplest part of this job, is connecting up all of the neutrals. Okay, so we have our 4 wires. So we'll go ahead and connect them. And you can see, I don't know how well you can see, but the copper wire has made it all the way to the front of the connector. So there's 4 wires here, but one thing that's going to make this job a little bit more tricky is I have to put the 3 wire in to run my 3-way switch. So if you ever run into this problem and you have too many wires, which you're going to run into too many wires, and you'll see later why with the copper wires, then what we're going to do is we're going to leave this last hole open, and we're going to put a jumper wire into another connector, which will connect up to this other neutral, and then we'll have the other wire from the 3 wire, the other neutral, that'll go in here. So then we're just going to put a jumper between here, and then all of these are all connected together. Okay, now for the grounds. Oops, almost put that last wire in there. So I don't want to do that, I want a jumper. So where this gets tricky with the grounds is that each one of these switches have a grounding screw. And what I like to do is put a little pigtail on here first, just a little piece of copper wire that sticks out maybe about 4 inches. And before I put any of these switches on, I'll just have that pigtail on, and then I can go ahead and connect these up, and then they can just kind of hang here, and then later on I can hook up my black wires. So just backing up a couple steps, let's go ahead and get our hots out of the way. So we'll get our black out of the way on the 3-way wire, and then this red is also going to be a hot. So we're going to get this out of the way as well. So now we have our copper wire, our neutral. So let me go ahead and hook up the neutral and get that out of the way. Okay, so now that we have all of our neutrals out of the way, or they're all connected, let's just get them out of the way. So just kind of neatly knock them all back in the very back. So now all we have to deal with is our copper wires and our hot wires. So as I was saying before, if we're gonna have our copper wires hooked up, we had to put in a jumper because obviously there isn't a connector that holds that many copper wires. So we'll hook up another wire, and another wire. So how I make these pigtails, I just take a pair of needle nose pliers, cut the pigtail, or cut the length of wire, and I'll just loop the wire around. And these screws go clockwise, so put your wire on so it hooks around clockwise. And then I'll take the needle nose pliers, squish the wire together, and then I'll just tighten up the screw. Okay, we'll make another jumper here. I can't imagine doing this with wire nuts. I've never had to put this many wires together. Luckily I found these before I had to put this many wires together. So what I'll do now is I have my wire on my switch. So I'll just plug that in and it can just hang there. Okay, I have my other two switches. Just pop these in place. And now I'm done with all of my grounding wires. Now I only want to hook up a couple of these switches because I don't want to make some of these wires hot, because I don't want to end up shocking myself. So here we have our three-way circuit. And you know it's a three-way circuit because it has two screws on either end and it has this black screw. The black screw is where the power comes in. So like on these switches, one of these screws will be where the power comes in, and then this will be where the power comes out. Not really specific on which screw you put the power in or power out, because like I said, all these do is break the black wire to break the circuit. These are very specific because you need the power coming in the black screw, and then the power leaves based on if the switch is up or down. The power leaves or the circuit's broken on one of these two screws. So this wire here is the hot coming into the box. This one wire is the wire that is traveling from the breaker through the Romex wire, and coming over and making this box hot. So the power from this wire is going to go through each one of these switches. It's going to jump over to each switch and power each circuit. I'm going to put a connector on the hot. And what I'm going to do after that is I'm going to take jumpers, and they're going to come off to each one of these switches. So let me just illustrate this a little bit better. So we have the box, and we have that one hot wire coming in that we just put the connector on. So let's just put the connector on. And then we have each one of our switches. Two of them have the screws on the side. And then the third one, remember, has the black screw at the bottom and then two screws on the side. So what we're doing is this hot wire is coming in, and then all we're doing is we're going to take a black wire, connect it to one screw, black wire to another screw, and this one has got to come down specifically. Remember, this has got to come to this black screw. So I made a pigtail for each one of my switches here. I only want two of these switches hot because I'm not ready to complete this just yet. So we have our hot wire coming in. I'm going to hook up the hots to the hot wire here. And now we need to figure out, based on the labels, where we need to land these other wires. So this black wire goes to the front light. And I do this with all the wires. I just strip them and then make a loop. The hot's coming in here. This is where it's going to make the break. And then this is going to connect the wire going up to the light. So when I turn the power on, these screws are going to be hot. So what I do is I take electrical tape and wrap them around the screws. And then somebody decides to stick a screwdriver or something in here, or I just don't pay attention one day, I won't get shocked. Okay, we have the light on the front of the garage. It's working. So these are called voltage testers. They're pretty inexpensive and they're really handy. What they do is you turn it on, and then anything that has power, it'll sit there and beep at you until you're about to die if you touch something. So a lot of people don't like these because they're worried if they work, you know, if they're working or not working properly. One way to test them is to go use it on something you know has power. So what I usually do is I'll go plug it into an outlet that I know is hot, and when I go plug it in, if this thing beeps at me, then I know it's working properly. Then I can come over to lights. I don't ever test this on lights. I always like to use something that's on all the time, like I said, like an outlet. So it's getting pretty late and I've got a long day tomorrow. Hopefully I can finish this up. It's Thursday now, so hopefully over the weekend I can finish up this video. What I want to finish up is get the other light at the other end of the building, get that hooked up. I'm gonna have 2 gang box over there, which will control the 3-way circuit coming into the building from that door, and then the other switch will control the light outside. So I hope to get that done. So one thing that I have to do tonight before I finish up is I have to adjust this light. So when I hooked up my other light on my garage, what would happen is the light would reflect down at the vehicle, at whatever car I had parked in front of there, and it would shoot back up at the light. So if you ever hook up one of these lights and it just sits there and blinks at you all the time, what it's saying is it shoots light, you know, turn it on, light shoots out, hits your car, reflects back up and hits the detector. Well, now the detector thinks, oh, it's daytime, so it shuts off. And then as soon as it shuts off, it goes dark again, then it says, oh, it must be night again, so then it turns back on, and you keep doing that, and it's just flashing back and forth. So what you need to do if that happens is adjust it so it doesn't hit your vehicles or anything there to reflect the light back up to the detector. So it's another day, and I got the other light on the other side of the building put in, but this is that front one that you all saw me install. You can see how the wire is just hanging, and eventually once it's all framed out, I'll get that wire hooked up so it's not just hanging there. So it actually looks like somebody halfway professional did it. And I don't know if you can see, but I have the wire going out through the top, and then the wire comes down to this box. So how that box is gonna get powered is it's gonna be on the same circuit as all of these lights underneath these, I don't know, like in these little cubby holes, I guess you wanna call them. So the power comes out of this box. That's where it sends it up to the light outside. But then if you remember from a couple previous videos, that's where that hot wire goes over to each one of these boxes. I just had to jump into each box. And as I described, the amperage that it would take to run all the lights, it's okay to put all of these lights on one circuit. So how this is gonna work is how everything just jumps across to each box. What I'm gonna do is, as it jumps across to this box here, and then it crosses and goes over to the office, I'm gonna tie in right here at this box. And so now the wire goes up into the ceiling there, and then it comes down to this box. So all I have to do right now is I have one wire that's gonna be hot from that other box, and then this will go up to the light. But to get that power, I have to make the connections in this box. And one thing I'm not gonna do, this Romex wire here goes up to that light. So what I can do is I can hook up, I'll leave this one out of the way, and I'll hook up all of these other ones with those connectors, or you can use wire nuts or whatever you want to use. And then all I'm gonna do is just bypass this light, and then later on I can just make a pigtail onto the black set of wires here, because all of these are going to be hot all the time. So what I can do is just make a pigtail that goes over to the switch, and then the switch will go up and turn this and send power to this black wire and turn the light on. So I have to do that in this box, and I have to make the connection here, and then that starts the first couple jumps. What I also have to be careful about This is something to keep in mind. And I guess I should have said this a long time ago. Obviously do all this at your own risk. You want to, be careful messing around with this stuff. I can try to show people how to do stuff, or anybody can try to show people, but it's kind of up to, you to get it right, or to figure it out, or realize that I'm an idiot and maybe I'm not doing it right. So basically you just want to make sure that you're not sending power somewhere where you don't want it yet, where it can't be terminated with a switch or can't be terminated in an outlet. Okay, so in this box, I have the wire. This is that first little cubby right when you come in the door. So I have the light wire. I'm not ready to hook up the light, so I'm just gonna get this out of the way. But I do need these other wires connected because I need to send power over to that next box like I just explained. I'm probably over explaining everything. I'm sorry. So what we're gonna do is strip these wires back, and I didn't quite leave enough wire in here, or leave enough wire sticking out. I'm gonna leave about 6 inches of wire. I kind of messed that up on this one. It's my building, so I guess I'll just deal with it. Okay, I'm gonna use these connectors that have 4 holes on them. Since this is my building, nobody's really around, I'm just gonna leave these sticking out. It's not a big deal. And so this is perfectly safe. You can turn on the power. As long as you've stripped these back about 3/8 of an inch, there's no metal showing, so it's no big deal. So in this box, I have the light, and then I have the wire. Let me just show you that it goes up and over to the office. So I don't want to connect this wire yet. So this is gonna be pretty simple again. Strip these back, and then just make the connections between the 2 wires. That'll send power over to the box with the switch for the outside light. You're really gonna have to think about this box if you were to do something like this. So what I have here is I have the wire to the light, and then I have the wire that's gonna provide the power from the last connection that I just made. So in this one, we wanna be careful. We don't wanna start hooking up different wires and things like that. We got to be really careful, because this wire, here, let me just strip it back real fast. So this is the 14-3 wire, which means it has the 2 traveler wires in it. And I'm gonna redraw this out for you and show you why I'm not gonna why I didn't provide power over here. Because the idea is the power jumps back and forth depending on whether you have like the switch up or the switch down. It depends on which one of these wires are hot. Okay, so we'll just do the simple one first. Once again, be careful with these utility knives or however you're cutting this stuff off. Make sure you don't nick any of these wires. And I guess if you have to nick one of them, nick the bare copper wire. So eventually all of these copper wires, all these bare copper ground wires, and all of the white wires will all be tied together when I'm ready to complete this portion of the circuit. So what you can do is they have these little holes in the back that you can just push the wires in and tighten them down. If you have the guys that come out and like rewire your house for like $14, that's what they're gonna do. Like if you get some of these big companies that seriously go out and replace like 10 outlets for $99, that's all they're doing, is they're just nipping these off, stripping them, throwing them in the back and tightening them down. I like a really good connection, so I twist these around. And then I just make sure that the wire is actually wrapped around, and then there's no way that you can have an issue. Well, there's no way you can have an issue that was your fault, let's just say. And just make sure you get these tightened down really well. I already made the little pigtail for my ground, so now I can just go ahead and plug that in. And the last thing I'm going to do is wrap some electrical tape around here. Okay, now flip the switch, see if we get light here. And there it is. So the reason I left the ladder leaning up against the building today is because I wanted to see how bright it is. It might look really dark to you, but it's actually lighting up the backyard pretty well. And I know my neighbors in the back have complained that my lights have, I don't know, they shine in their back windows. I don't really see it, I don't know. Let's see what this one looks like. So if I trigger this one, I don't know. I know you can't really see that right now, but it looks like they're about the same. I don't think one's gonna be worse than the other, so I think I'm gonna leave it like that. So in this box that I just finished wiring up, you'll notice that I didn't try to connect any of these hot wires to the hot wires to this other circuit. So really there's, I guess you wanna think of it, there's two different circuits in this box. And the reason you don't wanna get ahead of yourself, and I'm gonna draw it out for you here in a second, and if you saw my video, I don't know, 5-6 weeks ago, I know it's been a little while, you'll see why you can't just hook one of those wires up and expect to get power all the time. It's because with those three-way circuits, depending on which way that switch is flipped, you're gonna get power or not get power. And so I guess if you can figure out some crazy way to make it work, go ahead. But I'm gonna show you the simplest way to do these three-way circuits that you absolutely cannot mess it up. It's gonna cost a little bit more money in wire, but at the end it's going to work 110% of the time. I know that there's a bunch of these magical electricians that go out there and they find ways to connect the circuit, and then once some unsuspecting person comes in to try to fix some wiring or do something, then they got to sit there and figure out their mess. So I hope you can see this. I'm not going to draw as big. I need to get more of that cardstock. So remember, you have your breaker, and if you want to reference some of this more in detail, you can go watch my one of my other videos. So you have your breaker, and then remember you have the black wire coming out, and then remember on these bus bars on the sides, you'll have your white wire and your ground wire or whatever. They might be switched or however you decide to do it. Like I said, I'm gonna skip over some stuff. If you want more detail, just go to one of the other videos. So you have the black wire coming out, and then you have your switch, and it has a screw on the side. But then on the three-way, it's different because it has a screw on either side at the bottom. And the reason is because this screw here is always going to be hot. And what's going to happen is you flip the switch up and down. Say you flip it up, the power might run this way. But then if you flip it down, then it's actually going to connect the circuit this way. So if you have your other switch on the other side, that means that, say this is the red wire, and this is the black wire. So what's going to happen is you flip the switch up and down, it's either going to send power through the red wire, or you flip it the other way, it'll send it through the black wire. Which means the screws on the other side are going to be hot only if this is in the proper position, right? And then you're still going to have the screw on the other side of the three-way circuit, and this screw is what goes up and hooks to your light. So basically what you're doing is you're just kind of making a mirror image from the light or the breaker, and you're basically just hooking the light up to one screw and then hooking the hot up to one screw, and then these travelers are what go to the other two screws, and depending on what positions the switches are in, depends on if current's going to flow or not. So I'm not sure if it totally matters, but when I hook these up, I'm going to try to stay consistent. So say like the side that has the grounding screw on it, I'm going to put the red wire, or I could do it the other way. I could put the black wire on it, and then when I go over to the other switch, which is going to look exactly like this one, I'll do the same thing. whichever wire, black or red, that I put in. One side I'll make sure that I try to stay consistent. Just to try to keep it consistent, I'm gonna hook the red wire up to the screw that's on the same side as the grounding screw. And I'll just obviously put the black wire on the other side. So these don't actually have an on-off, so you can just put them whichever way you want. And the reason I don't have an on-off is because it just, all you're doing is just flipping the current one way or the other through the traveler wires. So as soon as I turn on the breaker, one of these traveler wires is gonna have current in it. So I'm going to leave the breaker off, and I'm gonna get the other switch hooked up properly, and then I'm gonna get the wire ran all the way up to the light, just to make sure I don't have any issues. Then I'll turn the power back on. I don't want to get ahead of myself, and I wouldn't recommend getting ahead of yourself either, because if you just start hooking stuff up, you got to remember that you've made some things hot. And so I just want to get the entire circuit complete before I turn it on. Okay, so here's the switch on the other side. So we have the black screw and the 2 screws for the travelers, and then the ground screw. So with this connector, has 4 holes. Here's the ground for the other circuit, but then we have another pigtail on this switch. So once again, just put a connector in the pigtail to the switch, and then a jumper wire, and then the wire to the other circuit. I'll need to trim this. Okay, now you have all the grounds connected, which I'm sure you've seen enough now. Now let's hook up the travelers next. So remember, on the other side, just stay consistent. The red was on the same side as the ground screw. And then the neutral is connected. So now the last part of this circuit, hooking up the hot wire going to the light on this black screw. Remember how I drew this out? So this light that you've seen before is the one that I'm gonna hook up. And all I'm gonna do for now, because there's gonna be 6 lights in like the main area here. And so what I'm gonna do for now is just take the wire, staple it up to the boards over here, and then run another wire up, and it'll just connect into it. And then later on, when I get all the framing done, the first box will be somewhere over here, and I'll have plenty of length that I'll be able to cut the wire there and just run it straight over to the box. But for now, I just need to complete the circuit over to the light. So there's the light. Here's just the temporary connections I made. The red connectors just have 2 holes, the orange ones have 3, and the yellow ones have 4. So if you're just gonna make a quick connection, these work really well. And these aren't that expensive either. So when I'm done, I'll just snip them off. and put the wire in the box. I know this isn't up to code, it's just temporary, so you know, don't worry leaving anything in the comments. So the wire comes over, goes down to the box, and I'll make the connections with the hot wire going to the black screw. That's where the power is going out up to the light. And then I'll just hook up the neutral just like normal, and I'll just hook up the ground to my connector here. Okay, let's try it out. So I'm gonna flip the switch. The light comes on. And then as I leave, come over here to hit the other switch. Light goes off. But we greatly appreciate everybody who's subscribed and has watched our channel and support our channel. And we hope to get more videos out more consistently in the future. Hopefully some things will calm down. I know I've said that like 14 times now, but some things are changing, so hopefully we'll have a little bit more time. Thanks for watching.